Okay, the first question, asking for transformation. So question number 1, we have f of x equals negative e to the power x plus 2 minus 3. Negative means what? Reflection. About x or y? X. Reflection about x-axis. We have plus 2 on the exponent next to the x. What type of transformation? Left. And then we have a single sad 3 down. See, it's single, that's why it's sad, that's why it's going down, negative 3. Now, horizontal asymptote. Where from we get horizontal asymptote? From the downward. So y equals negative 3. If you're at only negative 3, it's 1 point. That's why I showed here 2 points. One for y, one for equals 3. Negative 3. Okay, then when you draw, so it's down left. Yeah. The original graph, you always should draw it whether I tell you or not. So the original graph goes to the y value 1. We have e to the x. You are taking this graph and reflecting about x-axis. Means this one is going below x-axis. And this positive 1 turns into negative 1. And now this negative 1, you are transforming. You're going 1 left, 2 left here, and then 1 down, 2 down, 3 down here. So we have, this is here, this is here, and this is here. So you're drawing the same reflected graph, but here. So this is negative e to the x plus 2 minus 3. And you also have to draw your horizontal asymptote, it's negative 3. So this is negative 1, this is negative 2, and this is negative 3. This is the line you cannot cross. Y equals negative 3. Okay? So clearly show your boundary, your wall that you cannot cross, and then you graph. Okay? So, who got it correct? Almost. No. Okay, the next one, solving exponential equation. We have 25 to the x, what, plus 2 equals 125 to the 3x minus 1. So we have two different bases. Can you rewrite 125 as 25 to the some power? Is it possible? No. So this is, it's the scenario where we have two different bases, but we cannot write one base using the other base. So we have to change both bases. Can you write both bases in terms of a smaller base with some different powers? Perfect. And you keep your power same. X plus 2, 3x minus 1. And then what do you do when you have double powers? Before you equal them, what do you do? Distribute. So you get 2x plus 4. And here we get, if you distribute, 9x minus 3. And now we see both base are the same on both sides the equal sign. So we just cancel them. And we get 2x plus 4 equals 9x minus 3. How do you solve? Okay, we can do minus 9x or minus 2x. Personally, I like to keep my bigger one. But since you started with 9x, no problem. I already wrote it. Negative 7x equals negative 7 divided by negative 7, x equals 1. Really? So if this is 1, we have 25 to the 1 plus 2, which is 3. And this one is 125 is 3. 3 minus 2, which is 1. Does it make sense? 3 times 1 is 3. 3 minus 1 is 2. 1 plus 2 is 3. So 25 cubed. Oh, probably it's true. 25 cubed and 125 squared, they're same. Who knows? Yeah, so we get 5 to the 6 and we get 5 to the 6. And they are correct. When I did it mentally, I got a different answer. So I had to check. Oh, it's correct. But yeah, that says 1. Surprisingly, I just made the question up and you guys got the whole number. We do not have midterm, we have 3 exams. So in class, 3 in class and final. So our 2 exams are done already. The last exam when you come back from Thanksgiving. And then final. Final is cumulative. It's not me, it's the department. The department gave us the grading criteria. So I do not do anything besides deliver the lectures. That's it. Everything depends on the department. Okay, any other question before we start? Any question, comments, concern, complaint? Okay, so last class we talked about the application of exponential equations, and we came across 2 equations or 2 formulas. When you invest your money compounding at a certain amount of time in a year, then you use the first formula where you have an n to place how many times you are compounding. And if you do something continuously all the time, we cannot place a number on n. So that's why we use a different formula part. A equals P times e to the RT. And then we did several examples. And we realized if you want to get the highest money, the most money after investing, you should always use continuous compound instead of compound annually or daily or those. Compounding continuously will give you the most money. So today we're going to do 1 example, and then we are going to do exponential growth and decay on top of 12.4. So our very first question for today. How long it will take for an investment of $5,000 to double if the interest rate is 3.5% and if you compound annually? You're compounding annually. Which formula? The first one. The left one? No, the left one is only for continuously. So when you compound annually, that means you know how many times you're doing it in a year. How many times? Once. So see, you have a number for n. If you can place a number on n, then it's not the part formula. It's the first one, the big formula, which is A equals P 1 plus R divided by n, whole thing to the power nt. So how much money are you investing today? $5,000. 1 plus. What is the interest rate? 0.035. So to move your decimal 2 places to the left from 3.5%. And how many times you're compounding in a year? Once. So 1 times, what you're looking for? Which variable? T. So that means we're supposed to know our final amount. How much is the final amount? How do you get 10,000? It's right. Double. See, that's a smart move. If you want to double your 5,000, it has to be 10,000. So it is 10,000. So even though they did not give you money for the final amount, they left it on your logic. You need to figure out. So do you remember how do you solve it if you want to solve the variable on the exponent? What do you do? Divide by 5,000. So they cancel out, and here we get 1, 2, 3, we get 2. And this one, anything divided by 1 is the same thing. So this is 0.035. So if you add 1 with 0.035, what do you get? 1.035, and 1 times t is t. So everything is simplified. Now the problem is t is on the sky. We have to bring it down. Good. So we call log. Hey log, can you come home please? There's something stuck on the ceiling. Can you pull it down? So log is so nice. It comes right away. As a result, that thing comes down as a coefficient. I don't have space, so let me write it here on the next page. ln of 2 equals t times ln of 1.035. And now we are happy. T is a variable on the coefficient, so we can easily solve. What do you do? One point zero. They cancel out. We get T. So get your calculator out, either the actual calculator or your phone, whatever you have, and find out how much. No, in the exam, you're not allowed to do that. It's next to the log. You can use log here because you're dividing. If you're dividing, then you can use log. Mm-hmm. Two places. 20.50 or 15. 15. What do I have? Yes. 20.15. Is it or that? You're waiting 20 years. Yeah. I mean, it's not only 20, right? It's 20 plus more. So to add more than 20 years, just to double your $5,000 into $10,000. You can easily go to work and then earn $10,000.
How many formulas are
For money, there are these two formulas.
so compounded annually?
Compound any times that is visible, that is countable, annually, monthly, weekly, daily.
And the other one,
continuously.
what's the formula for that?
A equals P times e to the RT times e to the RT.
He is like,
E. The E is E. Now, built upon these two equations, especially the continuous compounding equation, the part equation, we have two realistic scenario or real application. One is called growth and one is called decay. So we want to see how quickly something grow or how quickly something decrease. And since it's continuously decaying or continuously growing, like for example, if you plant a tree, it doesn't grow annually, or it doesn't grow monthly or weekly or daily, right? It grows continuously. So anything grows or anything die, it does it continuously. So you have to use the part formula. And the ROC, it's specifically for money interest rate. So that's why when you work with real life application, they replace the variable R with K, but it's the same thing, the rate at which something is changing. So Y equals, for money, we write A equals P e to the RT. Now for growth or decay, it's the same thing, but we use F of T, which is like Y equals P e to the constant rate key and then time T. Same thing, just there's different variable. So they didn't get confused with money. The second one says, instead of P, we can use A initial. That 0 on bottom of A, it means A initial. It's the initial amount you have currently, and it grows or decay over time. Now, one application of the exponential growth function is doubling time. Like the last example we did, how long it takes to double something, doubling time. In real life, we use this function for wildlife population, like how population is growing, financial investment, biological samples, natural resources may exhibit growth based on a doubling time. These are the real life application where we actually use this formula. And since it's growing, so we get an increasing function. It's an increasing function of the exponential function. On the other hand, the decay function, it's decaying, means it's decreasing over time. So it has to go downward. It has to decay over time. So decay function is a decreasing function. And one example is half-life. It's like how long it takes for your life to get half. If you have $1 today, if you have $1 today, how long it will take for that $1 turn into $half, like 50 cents? How long it takes to get 1 to half? The isotope thingy, or what do you call bacterial growth is the growth function. Isotope life or platinum life, some type of chemical life, or those are mostly decay. So half-life is an application involving radioactive isotopes. You have no idea about them? I don't need to know them. Now one application. The population of something that they didn't mention here, the population of something in T years from 2000, the year of 2000, can be approximated using this model. P is the population, not the principal. The population equals 2000 e to the 0.05 T. So from 2000, the population is starting, and how it's growing, somehow they find out this formula. Now they are saying use this formula to approximate the population in 2015, in the year of 2015.
So, and
15. So our T is 2015 minus 2000. So initial year is 2000, the final year is 2015. The difference is going to give us the T, 15 years. So we are looking for the final amount of the population, how much they grew in these 15 years. So 2000 e to the 0.05 times we spent 15 years. Find out after 15 years, how much is the population quantity or something, whatever.
I need to put that in my calculator.
So here we have nothing to solve, we just have to simplify. We solve when we have variable on the top, variable on the exponent. Here we don't have any variable, we have all the numbers.
You do the same thing as L1.
E is same thing as L1? No, E is E. And L1 is log, E is exponential. If you don't see E, you're going to see EXP. So E is same as EXP in the calculator. Some calculator has E, most calculator has E, but some doesn't have any E, they have EXP, means exponent. Oh, no, E exponent, same. What I'm saying, come on. Sorry. EXP means exponent. What does that mean? It means the squiggly thing you see, it's the power exponent.
So the number that I just got is that people.
Population. How much population you have?
4,200.
For what?
4,236.
34. You know, my brain works slower when you tell me the details number. But if you tell me 4234, I can write easily. But I have to count 4,234. Like, do you guys brain work the same way or it's different?
Sometimes.
For me, always, like, if you tell me the details amount, I really have to think that in my brain, what that number is. Weird. Okay, let's see. What do I have here? Oh yeah, that number is wrong because we got the same wrong number in the morning. Something is no. Any question?
Wrong or right?
No, this is right. My morning class we got 4,000 or something like that. I don't remember exactly. But the answer we have is different.
So if we by accident use PERT on the test, like we won't get it wrong, but if we use the wrong formula.
No, it's not wrong. It's just different variables they're using, but they all represent the same thing. R means rate, K means rate. Okay, try the next one.
The R is for money question.
Hmm?
The R is for money.
Money. Specifically, R means interest rate. But here you're not working with money, you're working with rate, growth rate, or decay rate. It's a different rate, not interest rate. Oh, let me take that. It. Did you see today's date? 11/11. And now it's 1/11. 1/11, 11/11. What a coincidence. Okay, so we have today is what, 11/11. 11/11.
Yeah.
Ashley here. Jolisa. Michael. Lola. Here. Jonathan. Reina. Denisa. Samantha. Nicole. Andy. Ria. Andrew. George. George, are you done or you're calculating which one? Mariana here. Danielle here. Fatimata here. Azmain here. Shuing here. Chloe. Not Chloe. Kathleen here. Brennan here. Raim here. Shahana here. Leonardo out. Brian R here. Brian V here, right? Gian out. Alex here. Anastasia here.
Alan cancel E.
That's why when you have E, we specifically use ln. We cannot use log. ln and E they both cancel. Or we can use log, but then it doesn't cancel out. What else dropped? Ready? Brennan. E equals 50,000 e to the 1.31t. $130,000 equals 50,000 e to the 1.31t. By what? It goes to get the t alone t. So if you divide by 130,000, does it help t? So you need to divide by what? Who is next to the t? 130,000 or 50,000? So you need to get to the 50,000. So divide by 50,000. You told me 130,000, right?
I meant 50,000. I'm not 50,000.
That's why I'm saying, like, you see it clearly. Why are you telling me the other way? Okay, I see. So here we cancel out 10, 20, 30, 40. So left to 13/5 equals e to the 1.31t. So we are still having the same problem. T. Who wants to try? So in order to bring this t down, remember a few minutes ago I said you call Ellen. Hey Ellen, can you come home please? I need to bring that down from the ceiling to the ground. So Ellen comes on both sides. And E fights with Ellen. They both die. Elected ln 13/5 equals, what do you have? 1.31t. So you divide both sides by 1.31. So ln of 13/5 divided by 1.31. So you go to the calculator and find out how much is this.
0.73.
0.73. It is rounded to decimal places. So what number you have after 73?
Yeah.
729. So after rounding 0.73. Do any hear anything different than 0.73? Same? Good job. You should practice here because then in the exam, you have no idea how to plug everything in the calculator. Or how do you know whether you plugged in, whatever you plugged in is correct or not? Calculator is a very tricky thing, trust me. It follows PEMDAS really, really strictly. Okay, one more question. With coronavirus. When coronavirus first got into New York, first day 2 people got infected in day 1. And then rapidly, people are getting infected very quickly. Now, let's say the increasing rate is 26% per day. So every day, 26% people are infecting. So how many people got infected after 11 days?
No, sorry. 3 equals 2, right? E to the power of 0.26.
0.26.
Or it is 11.
It's 11 days, they're telling you. So it's like the part formula.
It's okay for me to.
Yeah. P means population, not the principal, population. Population. So after 11 days, how many people got infected? 35? It's just round to the whole number. So before, what do I have? 35, yeah. So before you round in, what number you had? 92. For example, you cannot round people down. For any item, people, anything, you should always round up. For example, you are finding that, like somehow you found out that you need to sell 2.5 item. But can you really sell 2.5 item? You have to sell 3 items. 2 items selling not going to help you. You need to sell 3 items. So the half item, you have to give them free. But it's not breakable. Something like human. Even if it's 34.1, you have to round up to 35 because it's human. You cannot have 34 human and then a piece of human. That piece of human means the entire human. So round up. So in realistic situation, we always should round up. One more question about half-life. So half-life of an isotope is 96 years. How much of 40-gram sample is left after 200 years? Many people do it differently, many different ways. How I do it is I always connect this with my part formula. Because then I don't remember any other formula. There is actually one formula for half-life, why bases have, but I always mess that up. So it's like, let me skip everything else and let me just remember one formula and use that for everything else. But no, it's half-life means you bases have, and then something you do something. But see, I always forget them. I always remember one method, and I can modify that method for every other question. So here we have two parts. This question has two parts. Why two parts? Because if you observe, do you know the rate, which is K given here? Did it tell you the decaying rate? No. Instead, what did they give you? They gave you 2 times. We need only 1 time. Why did they give us 2 times? We see the T twice, right? 96 years and 200 years. Why? They could just give us rate instead of time twice. So they didn't give us rate, but they gave us time twice. So one time we used to get the rate, and the other time we used to get the final amount. So this question has 2 parts. The first part is telling us about the half-life. So if today the initial amount is 1, what does half-life mean? What is final amount? Which is half, right? If initial is 1, half-life means the final amount will be half. So with this information, we are going to find the R, which is the K, the rate of decaying. So my part formula, A equals P e to the RT. What is the final amount? What's the final amount? 1/2. See, using these two information, initial and final. Our final is 1/2. Then what is our initial? 1. Do you know what is our rate? No. But did it tell us how long it will take to get 1 to become half? 96 years. So it takes 96 years for 1 gram to turn into half gram. Just using the first sentence, we need to figure out what is the decaying rate. At what rate the thing is going down, the thing is decreasing every year. So we have half equals e to the power 96R. Now what we are solving, R, right? And what is R? On the ground or on the ceiling? So whom do we call? The log. But we have to call special log. Which log?
Natural log.
Natural log, ln. We shouldn't use the normal log, log. We should call ln so that E dies. So E and ln, the fight. And we get 1/2. ln of 1/2, which is 0.5. So if you want, you can have 0.5. What?
It did 96 with 0.
It's years. Year. We cannot change year. We change rate. Yeah, it's negative because it's decreasing. The rate is decreasing. So 96R and divided by 96, divided by 96. That gives us a negative rate. How much? Negative 0.
So negative 0.007.
Give me more numbers because you have to use that.
00722.
00722. You shouldn't round here because you need this number to get the real result, the next result. So this is our rate, which is going to help us to find out the next portion of the question. Now we know our rate. Using this rate, they're saying how much of the 40 gram is left after 200 years. So today, how much you have of the isotope? Today, how much you have? 40 gram. So your final amount is initial e to the RT, R means K, Oh, we already have R here, so no problems. RT. Today we have 40 gram. And we know this time our interest rate is negative 0.00722. And how many years we are waiting? 200 years. So it's 40. Let me write a little bit closer. The initial amount is 40. This is what they're telling us. Today we have 40 gram. E to the our interest rate is negative 0.00722, and we waited for 200 years. So after 200 years, how much will be left from this 40 gram if it has a half-life of 96 years? 9.45 grams. Oh, this is not 9, this is G. So let me not write it. So this is the scenario. It's actually an interesting one. Let me just take a little bit time. Insert one page. So today you have 400 gram. After 96 years, the 400 will turn into how much? 20. This is what double half-life means. After 96 years, the total amount decrease double, not double, half. Now we have 20 gram. After another 96 years, how much it will become? 10 grams. So how many years you spent already? 6 plus 6, 12. 9 plus 9, 18. So 19. You spent 192 years, and the 40 gram turns into 10 gram. But they said you waited 8 more years. So 200 gram. Sorry, 200 years. You waited 200 years. Now, how much this 40 gram turns into after 200 years? It's definitely less than 10. To find exactly how much, we use this formula, and we get this is 9.45 gram. Okay. This is what half-life means. Any question? Guess what? So I introduced you total, I think 13 questions I counted in our morning classes, in our morning class. So all these examples from last class and to today's class, there are a total of 13 questions, and you have at least 2 of these in your final exam. 2 questions from these 13 questions. One will be in the non-calculator portion, I think, and one will be in the calculator portion. So make sure you learn all these examples. Try them on your own. Try them many, many times. And definitely they will be in the in-class exam. With this, you're done with 12.1, 2, 3, 4. Now you're going to a new section with a new type of function, logarithmic function. So what is logarithmic function? It's the inverse of the exponential function. So whatever information we learn about exponential, we are going to reverse them, and you'll get the information for logarithmic function. We write logarithmic function using log, and we use a couple of things. First of all, every log has a base. Sometimes it's visible, sometimes it's invisible. When it's visible, we can see the base on the leg of G on the right side. as a subscript. And when it's invisible, there is still a number, but that number is a specific number 10. So an invisible base is 10. A visible base could be any number. It could be whole number, it could be fraction, but it cannot be any negative number. It cannot be 0. And also whatever we have next to the log, we call them argument. This argument has one condition. It has to be bigger than 1. Bigger than or equal to 1. No, not 1, sorry. It has to be strictly bigger than 0. This A has to be strictly bigger than 0. It cannot be 0. And this B, it cannot be negative or 0. So it has to be strictly bigger than 0, but also it cannot be 1. It can be every other number besides 1, which is positive number bigger than 0. Now, logarithm and exponential, they are interchangeable. It means you can convert log into exponential into log. Why do you care? Because sometimes maybe solving exponential equation is harder, so we get the help from the log. And basically, we actually don't know how to solve logarithmic function. Anytime you're trying to solve the logarithmic function, you must convert them into exponential. So that's why they are interchangeable. We change one format to another format whenever we need it. How do we change? We use like a cycle. So whatever we have for the base, that base gets the right side of the equal sign, or the right side of the equal sign. Different people call it different things. Some people call it just value, like the y value, and some people call it exponent. They call it exponent because the base gets that thing as an exponent. And then we set that equals to the argument. So the base gets the right side of the equal sign as a power equals the argument of your log. That's how you convert from log to exponential. We just go in a cycle. Let's do some example, things will be clearer. Who'd like to try the first one? Log base 5 of square root of 5 equals half. Convert into exponential format.
5 to the power of half equals.
So 5 to the power 1/2 equals square root of 5. And this is true. 5 to the 1/2 is same as square root of 5. So you can check your work, whether whatever you have, is it correct or wrong. So you start from base always. Base gets the right side as a power equals the argument. Anyone would like to try B? Daniel.
3 to the power of -3 equals 1.
And this is true. 3 to the -3 is 1/27. Using exponent rules. 3 to the -3 is 1/3 cubed, and 3 cubed is 27. So you start from your base. Base gets the exponent as a power, and then we set that result equal to the argument of the log. Go ahead, Mariana.
The power of 1/4 or 4
Fourth root of 6. No problem. You see how easy to go to exponent from log. So for exponential function, we call the log. But for log, we don't have to call the exponential. We can convert the log into exponential. And then there will be normal log. We can do the other way around. For exponential, we can convert them into log. So if we do convert them into log, we have log. We need some base and then argument equals something.
Log of 6.
What's the base? What's the base? Base is 6. And what's the argument? Square root of 6. And the right side is 1/2. I always have to check whether it's correct or not. So I convert 6 to the 1/2 equals square root of 6. Correct. I'm good at log to exponential, but I'm bad at exponential to log. Next one, who would like to try next one? We need a base, argument, and the value of the exponent. Mariana.
The base is 5,
Mm-hmm.
the argument is 1/5,
Mm-hmm.
and negative 1.
The other side. Just let's check. 5 to the 1/2 equals 1/5. Yep, this is what is given to us. Any question? And you need to know this conversion because when you solve logarithmic equation, you have to convert them into exponential equation. Little bit information about the log and exponential. Log and exponential, the inverse of one another. That means the x value for the exponential is the y value for the log. And the y value for the exponential is the x value of the log. And domain of the exponential is the range for log, and range for the exponential is the domain of the log. Also, another one huge difference is that, see, there are many differences. One of the visible difference is that exponential functions, it takes a small number, but gives us a huge result. It produces a big number. For example, 2 to the 5. How much is 2 to the 5? 32. And what is 5 to the 5? Any idea? At least what is 5 to the 4? 625. You see? From 2, you get 32. Oh, it doesn't seem so big. But from 5, you get 625 just by getting 4 power. So exponential function takes a small number, but the result gives us a big number. Since log is opposite of the exponential, it does the opposite. It takes a big number, but it produces a small quantity. So the log makes things smaller and exponential makes things bigger. They're really opposite of one another. Another difference is that log, okay, so they actually have the same graph, okay? It just doesn't look same. Our exponential graph is the blue graph. Every exponential graph without any transformation has to go to the y value 1, and it's increasing if our base is positive number, whole number. Same graph is true for the log. You just have to reflect about y equals x line. So this is the y equals x line, like this is the mirror. If this is the mirror, and you look at the exponential graph in your mirror, the graph you see, that will be the logarithmic graph. Now, logarithmic graph, every logarithmic graph without transformation goes to the x value 1. So see, the opposite. Exponential goes to the y value 1. Logarithmic function goes to the x value 1. Previously, you also learned that every exponential function has a horizontal asymptote. What's the opposite of horizontal line? Vertical line. So every logarithm, they have a vertical asymptote. Okay. So horizontal asymptote is y equals some number. Vertical asymptote is x equals some number. They're opposite of one another. Also, do you remember where from we got the horizontal asymptote? We got the horizontal asymptote from up or down transformation. Do you remember? Can you guess the vertical transformation? Where from you're going to get this vertical transformation? Left, right. They're totally opposite of one another. They're like two enemies, like, if one goes up, other has to go down. If one goes left, other has to go right. Like they hate each other so much. Now let's show you some graphs of log. You may wonder what base does on the log. The bigger the base, the closer they are to the x-axis. The red example, this has base 2. The next one has base 3. You see, the 3 base is closer to the x-axis. This is our x-axis. The 3 base is closer than the 2 toward the x-axis. The next graph here is base 10, log base 10. So you get even more closer to the x-axis. And the last blue one, it's log base 200. See, it gets very close to the x-axis. So the bigger the base on the log, the slant, the more they lie down. The more closer they get to the x-axis. The more closer, double more. Question?
So never did the x-axis.
Never. Without any transformation. And you already talked about the asymptote. We have a vertical asymptote, and that vertical asymptote we get from the left-right shifting. So left-right shifting means we have a number next to the x. So if you have x plus 1 is set equals to 0, your vertical asymptote is x equals -1. If you have a number x minus 3 is set equals to 0, your vertical asymptote is x equals 3. So whatever you have next to the x, you take its opposite. For example, we had 2 questions. We actually have more examples, but here we have 2 examples. Let's see. We have a 2 next to the x. Which shifting?
What?
Transformation.
Left.
Left 2. So you draw the original graph. The original logarithm, it's an increasing graph. It goes to the x value 1. This is log base 2 of x without any transformation. Now you take your x-intercepts and you're going left 2 units. So left 1, left 2, you're landing here at -1. And then you're going to draw your new logarithm graph, which is log base 2 of x plus 2. But it has a boundary that you cannot cross. We call it vertical asymptote. What's the vertical asymptote? -2. Because you have to take this x plus 2, so it equals 0, so you get -2. So -2 is here. So you have to draw your boundary, your wall. That graph gets very close and close to the wall, but you can never cross that wall. It's a very electrified wall. It cannot get close to that. You cannot pass it. How about the next one? We have a -5 inside the. It means it just got closer to the x-axis. So visibly when you draw, we don't see any change. If you draw using a calculator, then you can see the change. Otherwise, they're all same. The base doesn't matter. So x -5, which direction you're going? Right 5. And we have a +2 extra. Up 2. What is your vertical asymptote? X equals 5. So you take x -5, so it equals to 0. That tells us it's x -5. So you have all the information. So upright. Let me draw here. This is the normal log base 3 of x. It goes to the x value 1. So 2, 3, 4, 5, 6, 7. You're taking your x-intercept and you're going right 5 units. 1, 2, 3, 4, 5. You're landing here. And then from here, you're going up to 1, 2. So go from right, from 1 to you're going 5 right, and then up 2, and you're doing the same graph here. Log base 3 of x -5 plus 2.
Vertical.
Why is vertical asymptote? X equals? So 2, 3, 4, 5. This is the line that you cannot cross. This is our wall.
There's no horizontal.
Because it's going up forever. It's just growing slowly. Slowly, slowly, slowly. But eventually it's going to cross the entire y-axis.
So, vertical or
So exponential takes vertical, no, exponential takes horizontal, and log takes vertical. So all you have to do is remember one of them. If you can remember one of them, the other one is opposite. So whatever is easier for you, remember asymptote for that. And these are the actual pictures. Okay, try one with all three. Oh, and then I had 2 more. Try 3. They don't have much difference. They both are log. They all are log, not the both. Oh, and in the exam, in the final exam, they ask at least one of these, either from the exponential or from the log. You have to graph them in the final exam. But in the in-class exam, you have to graph both of them. One exponential, one log. Solving one exponential equation, solving one logarithmic equation. Solving one exponential real life. We don't have any log real life. So no.
Friday? Are you coming in short quiz or?
No, not this Friday. And next week again. You're only 10 minutes. Why you guys are moving? Why you guys are leaving? You still have 10 minutes. At least 10 minutes.
Whole point. And you, and then like you least like maybe like 5-7 minutes, you come back and maybe then left.
Wow. Do you guys hate this class? Hate this class that much?
In the middle.
So you understand. It was emergency. But now they're going, they know it's only 10 minutes left. So what's the point?
I wish you were.
Pick help?
Oh,
No.
kind of like worried for it, because like, I have to take it. I'm like,
Which math you're going to take? 2001 or 2001? Yeah. I'm thinking to request the department to give me 2001. Because teaching the same class twice is so annoying. I hate that. Yeah.
And then like, I do the thing is like, I do have to take it in spring semester because like, all of the other classes, they're all locked.
Mm-hmm.
Off and on.
It's the prereq for everything.
2000.
Sure.
Some concept.
Oh, yeah.
2001.
So in 2001, the first part is 1030, what we are doing, the first part. And the log, especially the log, it's the first part. And the second part is trigonometry. Do you know what is trigonometry? Sine, cosine, tangent, those things. Unit circle, solving trigonometric equation, those things. And 2001, 2003, and 2009, that's the same class. 2009 meets 4 days a week, and 2003 meets twice a week. That's the difference.
That out of
I
these,
took 2000.
the 2001 is that
In 4 days, we had 3 lecture and 1 tutoring session, recitation. But it's the same material. I mean, it's the same material for both 2003 and 2009. And it's half calculus, half pre-calculus. Are you guys done? George, help me with C, please. Do you want to draw it? It will be fun. Okay, so negative means reflection about x-axis. -5 inside. Left or right? Right. Right 5. And +2? Up 2. And what is this vertical asymptote? X minus 50 tells us x equals 5. So right 5 up 2. 1, 2, 3, 4, 5, 6, 7. So you draw the original graph, log base 3 of x. And then what did you do? Reflect. So when you reflected, what type of graph you got? Going downward. So this top portion goes here on the bottom. And then that reflected graph, you moved how many units? 1, 2, 3, 4, 5. And then 1, 2 here. So I draw the same exact graph. And why is your asymptote? So you always have to indicate your asymptote, the wall that cannot cross. X equals 5. Any question? Shahana, the next one. Help me. We have a -1 inside the parentheses next to the x. Which one? Remember, left, right goes opposite direction. So minus supposed to go left. But does it go left? Right. It doesn't have any other transformation. It's a simple one. This is the normal ln of x. It takes you intercept 1 and goes. It goes 1 and to the right. So here. ln of x minus 1. And you have to indicate its asymptote. What is its vertical asymptote? No. X minus 1, 0. So x equals 1. So this is your vertical asymptote, this line, x equals 1. Yeah. So if you erase the original graph, you can see the vertical asymptote clearly. That's the vertical asymptote. Okay, any volunteer for the last one? Rahim. Reflection about x-axis. 1 left, 2 down. So that also tells you vertical asymptote. What is your vertical asymptote? No. Vertical asymptote comes from the inside. So x plus 1 is stated equals 0. X equals -1. It will be -2, right? Before? It's -1. From the x, from the left, right, not from the up, down. Up, down is taken by the exponential. So you cannot use that. So we're going left. So let me use this. Left and down. Okay. So this is the original ln of x. The negative version, the top part, the above of the x-axis goes below the x-axis, and they switch the position. And now this reflected graph, you go 1 left means here, and then 1, 2 down means here. So 1 down, 2 down. And we cannot cross x equals -1. So draw your wall and then draw the graph. So this is the final product. ln of x plus 1 minus 2 with the negative sign in the front. Please remember the shape. I don't want to say any weird shape in the exam. For the cubic graph, I still remember. Somebody draw the cubic graph this way. So at first I was like, okay, I'll assume it's a cubic graph. And then it looks so weird that I was like, no, there's no it's a cubic graph. Like, how is a cubic graph? It's like a wave. It doesn't look like a cubic graph. Cubic graph, first of all, doesn't go this way or that way. It goes, this is a cubic graph. It goes straight up, straight down, a little bit slantingly, but it doesn't go like a wave. So, yeah. So please do not give me any weird shape. Remember their shape very well. Now we have 2 sets of properties. Just copy them for today. We're going to start with these in our next class. And you need to have them. I will show them, but you don't have time to start. You don't have time to copy because we're going to do all these examples. Oh. So next class will be built upon these things. So we have 3 days before next class, right? Take a look at them. then the next material will be easier for you guys. Have a good day, everyone. Be safe.
You too.
Well, like into chapter 12, because I was preparing for today, but it's just two of the midterms and same as in 3 chapters in chapter 11, and a chance for a few days of extension.
Okay, I'll extend them for 1 more week.
Well, it's just like, like what I had for the midterms. But I'm gonna be honest, I was like,
I can help. As long as you do them, I'm happy.
I'm done with chapter 12.1, 12.2 because I was preparing for the quiz today, but like the other ones.
Smart move.
Okay.
When will you post this recording?
Today night.
Okay.
Okay. Bye. See you in the next class.
Thank you so much because you were like,
No problem.
you see snow today?
Snow?
It was
snowing?
in Manhattan like this morning.
Really?
15 minutes, yes.
Wow, I missed it.
First snow
Thanks.
in my country. Like it's actually interesting that like we have like, since Europe has like old traditions, like very old. So we have like that exactly on today, 11/11. If it snows, it predicts a long and cold winter. And it will snow. I was like, wow.
Yeah.
I was like in the morning looking at
Interesting.
It's like, I was like, wow, I can't believe it actually. It snowed.
So it is only for 11/11 or some other
Yeah,
days?
because like, I mean, like, like, it's connected to like Christian like holidays and this. It's called San Martin Day.
Mhm.
And it was like back then, like in the days when people like lived on farms, right?
Mhm.
So 11/11 is connected to like a sort of like first day of winter season,
Mhm.
where like the farmers, they were like, by that time they must have been ready for the winter. Like the crops must have been harvested and everything must have been
Mhm.
like ready. And like on 11/11 they celebrated the start of the winter. And it's like, if it snows, the winter will be like cold and like long.
Yeah.
I'm very happy about it. I just liked it because I haven't seen snowing on this day like for years, literally. That's like, I'm like, wow.
So you're excited.
I prefer cold weather over like the super hot weather.
That's true. Me too. I like cold compared to hot.
It's just easier, like, you know what? So you wear layers, you wear like warm jacket. But like in the summer when it was like so hot this past summer, like I was struggling.
True. So George, you're the only one who is really copying, and everyone else was just taking pictures.
Yeah.
Oh, you did? Thank you. See the 5 minute I assigned to copy. Where is my class?
I will do it at home. No, I can show you because my pen literally gave up before doing that. So, and it's not an excuse. Like,
It's okay, I understood. I just wasn't expecting these.
look, even when we were doing the last one, it was like struggling. Thank you. Have a good day.
Bye.